Alright, Algebra 2, this is finding slope and rate of change, second video. So we're starting here with parallel and perpendicular lines. So why don't we start by getting these definitions written down. They're not really definitions, but just to differentiate between the two. So parallel lines have the same slope. Okay, it's just the exact same. And so if we remember, a line in slope-intercept form is y is equal to mx plus b, where m is the slope, right, and b is the y-intercept. Okay, so whatever the value that is in front of the x, that's your m. So we have the m here is 2 for this line right here, and the m for this other line here is also 2. So these slopes are the same, which mean these lines are parallel. Okay? And so that was pretty easy. Perpendicular is a little bit more tricky. So perpendicular lines, perpendicular is going to create a right angle. So these would be perpendicular lines, and so they're going to create a right angle. So we're going to notice, like, okay, with this line here, right here, this is going positive, right? This is a positive slope, and this is a negative slope. But it's not just negative, it also has to be reciprocal. So perpendicular lines, their slopes are negative reciprocals, or I sometimes say they're opposite reciprocals. Just saying that one has to be positive, one has to be negative, okay? And they have to be reciprocal. So here is my slope here for this line here is -3, okay? And my slope for this line here is +1/3, okay? So to write this slope for the first line here, m being -3, this is a whole number, but as a fraction, we could write that as -3/1. So if we flip that, that's all a reciprocal means. You just take the numerator and the denominator and you switch the order. Okay, so this one is -3/1. So they're reciprocal, we switch it, and then we make it positive. Okay, that's why I say opposite over negative. Okay, hopefully that makes sense. Let's take a look at some examples of this. All right, I'm going to pause the video here. Okay, there we go. So we have line 1 goes through the points -2 and 2, and also 0, -1, and line 2 goes through points -4, -1, and 2, 3. Okay, so what we need to do is just find the slope for both of these. All right, and so this is using the equation that we had yesterday. Maybe I'll rewrite this out again here. We have m is equal to y2 minus y1 over x2 minus x1. Okay, so let's see here. Let's go ahead and label these x and x2 and y2. Okay, so we'll go ahead and plug these into the formula. Y2 minus y1 is going to be -1 minus 2, and x2 minus x1 is going to be 0 minus -2. So we're going to get -3 on the top, and 0 plus a +2 is 2. So we have the slope of -2/3. Okay, right? If one is positive, the whole thing is positive. We'll just rewrite that like that. And let's see, we'll do the second line. We'll figure out the slope here. So again, we got x1, y1, x2, y2. And let's go ahead, we get 3 minus -1 over 2 minus -4. Looks like we gotta change all these signs here. We get 3 plus 1, that's 4 over 6. Reduce this. If you're not sure how to reduce, just enter the fraction in your calculator and press enter. +2 over 3. And so, there anything significant about these? Are these parallel, perpendicular, or neither? Okay, we see that one is positive, one is negative. Okay, and then also this is 3 over 2 and this is 2 over 3. Okay, so these are perpendicular because these are negative reciprocals. Okay, negative reciprocals, which means so these are perpendicular. So lines 1 and 2 are perpendicular. Okay, all right, let's do the next one. Maybe you guys should pause the video and give this one a shot first, and then we'll go through it. So pause the video, try this one. All right. Okay, so we need to first find the slope of line 3. All right, so we're going to do m of line 3 is equal to negative 3 minus 2 over 4 minus 1, and we get negative 5 over 3. There's the slope of line 3, and line 4, let's see, we're going to do negative 2 minus 3 over negative 1 minus negative 4, and we get negative 5 over, let's see here, minus, and there we go, this is going to be 3. Okay, look at that. So we get the same slope, which means these are going to be, so lines M and M3 are parallel. Okay, all right, moving on. Let's see here, what else we got? Okay, we've got the definition of rate of change. So we'll get this written down. We have the slope that represents how much one quantity changes on average relative to the change in another quantity. Okay, and the units are important here. So pause the video, write that down. And now we'll take a look at number 7 here, example number 7. So this question, or these two questions here go with this diagram. It's not on your paper, so you can just write a little, draw a little picture if you want to. What is the rate of change over time, and can you predict the diameter in 2065? So let's take a look at this picture here. All right, so we have, this is, there's not a whole lot of context in these pictures, but this is the diameter of a tree. Okay, and so in 1965, the diameter, right, the distance across this circle here was 137 inches, and in 2005, it was 141 inches. So this might seem hard, but all we have to do is convert these into points. Okay, so we're going to say in 1965, we were at 137. There's 1 point. And in 2005, whoops, there we go, 2005, we're at 141 inches. So what we need to do is find this rate of change, which is just looking at the slope. So we're just going to say x1, y1, x2, y2, and just go ahead and figure this out. So let's see, we're going to do y2, we're going to put the inches on top, so we're going to do 141 minus 137 over 2005 minus 165, and you can go ahead and calculate this out. We're going to get 0.1 inches per year. Okay, so let's see, that is my rate of change over time. And let's see, can you predict the diameter in 2065? Okay, so from the point of reference here of the last data point of 2005, 2065 would be 60 years. So basically what we're going to take a look at here is like our y here is what we're trying to figure out, and we're going to do 0.1 times x plus the 141. Okay, and so what we're going to do here is type in our x is going to be the years from 2005, which would be 60, So we're just going to go ahead and type this in or substitute this out. So we get 0.1 times 60 plus 141, and we should get y is equal to 147 inches. All right, so it looks like in those 60 years, it will grow 6 inches. Okay, moving on. So for these story problems, you will have some story problems on the test. Just make sure you're labeling them correctly, and then it's really the same thing we've been doing with our points, okay? So a car uses 3 gallons of gas for 50 miles in one trip and uses 9 gallons of gas for 140 miles on another trip. What is the average rate of change in miles per gallon? So again, all we have to do is call this our x and our y. There we go. So just put points out, 3 and 50 and 9 and 140. x1, y1, x2, y2, and we just follow the formula, right? We're going to do 140 minus 50 over 9 minus 3. Go ahead and solve that. We get 90 over 6. And we divide that. We get 15, and this is miles per gallon. Okay. All right, why don't you guys give these two a shot, pause video, and then I'll go through them in a moment. Okay, hopefully that was enough time. So we've got some decimal here, but that's okay. So we got 0.1 minus 3.2 over negative 2.5 minus 4.5. So we get negative 3 over negative 7. Remember, if they're both negative, that means the actual answer is positive, right? Negative over a negative is a positive. And so this is the slope here. Let's check the other one out. We got 3, 3, and 10, 10, or 10, 0, sorry. So we're going to do 0 minus 3 on top. Change in y's over the change in x, 10 minus 3. So we get negative 3 over 7. All right, this is one that usually confuses students. We have 1 is positive, 1 is negative. A lot of students will say, oh, that's perpendicular. This is not perpendicular. This is neither, okay? They not only have to be opposites, but they also have to be reciprocals, and these are not reciprocals, so these are neither. Okay. Last one here, and then you guys can work on these practice problems. After 2 months, a baboon plant was 1.7 inches tall. Okay, so let's see, we're going to have months as our x and inches as our y. After 8 months, the same plant was 12.4 inches tall. So again, x and y. Find the rate of change in terms of inches and predict how tall it will be after 1 year. All right, so just go ahead and convert these into points. We got 2 and 1.75 and 8 and 12.4. Okay, again, x1, y1, x2, y2. Just follow the formula. So we do the changes in y first. So y2 minus y1 over x2 minus x1, and we get 10.65 over 8 minus 2 is 6. We just go ahead and convert this. Just go ahead and divide, and we get 1.775 inches per month. All right, that's all I got for you today. Why don't you guys give the rest of these practice problems a shot? If you need help, come see me on my Google Meet. Thanks.